this notation means. Now some of you guys with your, you and your conceptual understanding of everything were able to figure it out. I think Allie cheated. Did you put .001? Total cheat. Total cheat. But she got it right. She put in .00001 here and here. And just found what it was close to.
I did that too.
You cheater. Did you do that?
Yeah.
Talk to me. I might give you points. If you did it, I'm like, okay, fine. You'll know where it's going. For something like this, you won't have a calculator on the test, you know. Understand that what this is asking, what is this asking? What is this question asking? What does that mean? Like, what is this asking? This is asking you a question. Yeah, this is asking you, for what is that instantaneous rate of change? What's the change in y or change in x? For a really small interval for this function where? At x equals 4. Does that make sense, you guys? This is the definition of the derivative. Now we don't need to do this the long way. We know how to take the derivative of this and then plug in 4 correctly. Does that make sense, you guys? No wrappers. We can do this now if you recognize it. Does that make sense, guys? But recognize it. Recognize what this is asking, because that's what the test is going to ask. It's going to show you something like this. And it looks like a bunch of jibber jabber. Until you say, oh, wait a second, I've seen things like this. Something cubed plus something squared with a plus h and then minus the same number. Or, oh, that's the, the difference quotient for the x cubed plus x squared function. And again, you don't plug 4 into this, because that's just what's the function value at 4. This asks for instantaneous rate of change at 4. Does that make sense, you guys? So we talked about it. We spent a couple minutes when we were talking about the quiz. It's here again. It's going to come up again. And next time you're not going to have use of your calculator to stick in that .0001. Okay? Does that make sense, you guys? Okay? Now the other one. Now let me see here. The second one. So I was really picky. You guys may not like it, but I'm getting very picky on these. Because I want you guys to put everything correctly. Start getting used to it now. I love this on the bottom. This is what I loved about this one. For the first part, we'll talk about that first. Is it continuous? How do you test if something is continuous? I saw a bunch of these huge explanations and all this stuff, and I don't need any of that stuff. How do you prove something's continuous? Don't know. How do you prove something's continuous?
The derivative from the limit value equals the function.
Limit value equals the function value. How do you prove something's continuous? At a point. You just said it. Say it again.
Limit value equals the function value.
How do you prove something's continuous? At a point. The limit value equals the function value. And don't just say that. I need to see the numbers. A lot of you guys were taking the cheat. I don't know if you knew it or not. I did see some numbers up here. But a lot of people just here would say limit value equals function value. But I don't know what that value is. I don't know if you know it or not. Does that make sense? State limit as x approaches 0 from the left and from the right. And technically, I still need to see, even though these are the same, I still need to see that you know that then the limit as x approaches 0 of f of x equals -1. And f of 0 equals -1. That's your proof for continuity. Limit value equals function value. Question?
Don't you also need to say that there's a y value for every x value within the domain?
Are you talking about the whole function?
Yeah.
So you're talking about the whole thing. This is continuous, and this is continuous. So you only have to check the points where they meet up.
Okay, but isn't that sort of a one reasoning? Like, if you don't say that the definition of something being continuous, so that there's a y value for every x value.
Our definition is limit value equals function value.
Okay, so it's okay if there's like a gap as long as
There is no gaps if all limit values equal function value. Because that means the limit's always equaling the whole. Like you're filling every hole at every single point. Does that make sense?
yeah.
There are no gaps if limit value equals function value. Yeah.
So So then, if we say like limit as x approaches 0 of f of x equals -1, we have to say like for left and right too.
So if you show me somehow that you know, like for these types of problems with the left and right, like the goal is to see that you check the left and the right. You know what I'm saying? Or somehow I have to see like for the checking, because otherwise this is all good and this is all good. You know, and usually you don't have to check if it already is a continuous function. Being a continuous function, it means like it, you know, it's all good. But just let me see this limit from the left, limit from the right, the limit then, and function value. With that, you're good. You know what I'm saying? You have anything, no one could ever take a point away from you. You know what I'm saying? And that's what I want you. I don't want anyone. You know how to do it. Now make sure you earn every point that you're owed. You know what I'm saying? And having all of that, you're good. Now, you guys check out this one. Here's why I like the notation again. If you want to know something's differentiable at a point, how do you check that? How do you check differentiability at a point? What do you have to check? Yeah, first it has to be continuous. And that's why some people are doing yes and no. So I give you points, yes up here, but no on continuous. But you have to be continuous first in order to be differentiable. If you're continuous first, then you check derivative from the left and the derivative from the right. And just look at our notation. Isn't this nice, you guys? Isn't that saying that? The limit as x approaches 0 from the left of the derivative is 1. Do you see that? And the limit as x approaches 0 from the right of the derivative is 4. This is saying the value of the derivative from the left is 1. Well done. Okay, does that make sense, you guys? Okay. So, look at it. Write a note on it. It's going to come up again. These little piecewise things have come up a whole bunch of times. Again, write on your flashcards, which you all have been using on the weekends. You were going around trick-or-treating between houses. You were looking at your definition of continuity. You were looking at the definition of chain rule. Just so you get used to it. Again, no one's going to laugh. You can say that you're a nerdy mathematician and you're going around, look at me, I have derivative cards. Only, you're really just practicing. You're like tricking them. Does that make sense, guys? Okay? Alright. I want you guys to answer this question in your groups.